October 15th, 1944, 0347 hours, Artillery Command Post Bravo 7, Hürtgen Forest, Western Germany. The silence that had settled over the forward observation bunker was more terrifying than any barrage Colonel Heinrich Brenner had ever experienced. For the third consecutive night, his artillery batteries had opened fire on American positions, and for the third consecutive night, counter-battery fire had found them within minutes of their first salvos. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The mathematics made no sense. Brenner stared at the casualty reports spread across his field table, the numbers illuminated by the flickering light of a kerosene lamp. 12 105mm howitzers destroyed in as many hours, 8 150mm guns knocked out of action, 37 experienced artillerymen dead, another 63 wounded or missing. The counter-battery response times defied every principle of indirect fire doctrine taught at the artillery schools in Jüterbog and Idar-Oberstein. 4 minutes and 37 seconds. That was the average time between the moment his guns fired their first rounds and the moment Allied shells began falling on their positions. In the darkness of the German forest, with no visible observers, no aircraft overhead, and perfect concealment provided by the thick canopy of pine and oak, American artillery was locating and destroying German positions with a precision that violated every tactical manual ever written. Brenner had commanded artillery units since the Poland campaign of 1939. He had directed fire missions across the steppes of Russia, through the desert campaigns of North Africa, and along the Gothic Line in Italy. Never had he witnessed counter-battery fire delivered with such devastating accuracy and impossible speed. The Americans were achieving what German fire control doctrine insisted was tactically impossible: real-time location and engagement of hidden artillery positions in heavily forested terrain during complete darkness. The reports from his battery commanders told the same impossible story. Guns that had fired from concealed positions, carefully selected for maximum cover and concealment, were being targeted as if American forward observers were standing directly beside them with field telephones. Batteries that had displaced immediately after firing, following proper shoot-and-scoot tactics, were being engaged at their new positions before they could unlimber and prepare for their next fire mission. The crisis that was developing in the Hürtgen Forest represented more than tactical inconvenience. German artillery doctrine depended on the fundamental principle that indirect fire weapons, properly concealed and tactically employed, could deliver devastating firepower while remaining relatively invulnerable to counter-battery fire. This principle had held true throughout 5 years of warfare across 3 continents. American forces were systematically destroying that assumption with technology that German intelligence services assured field commanders did not exist. 3 kilometers southeast of Brenner's command post, Major Klaus Dietrich received the latest situation report from his forward observation teams. The 2nd Battalion, 276th Artillery Regiment, had lost 6 guns in the past 48 hours. Each engagement followed the same pattern. German batteries would commence firing on American positions, deliver perhaps 2 or 3 rounds per gun, then find themselves under accurate counter-battery fire from multiple directions simultaneously. The speed of the American response suggested intimate knowledge of German firing positions before the first shots were fired. Dietrich had repositioned his batteries 4 times in the past week, selecting new firing positions according to the most stringent concealment criteria. Each new position was discovered and engaged with the same terrifying efficiency. His battery commanders were beginning to whisper about American spies with radios, transmitters, though Dietrich knew that even the most sophisticated espionage network could not account for the precision and timing of the counter-battery responses. What troubled Dietrich most was the ammunition expenditure reports reaching him from prisoners and intercepted radio transmissions. American batteries were achieving their devastating results while firing fewer rounds than German doctrine suggested should be necessary for effective counter-battery fire. Conventional counter-battery tactics required extensive bracketing, adjustment, and multiple firing phases to achieve accurate hits on enemy artillery positions. The Americans were achieving direct hits with their opening salvos, as if they possessed precise coordinates for every German gun position. The technological implications were staggering. Accurate counter-battery fire in forested terrain during darkness required either visual observation, sound ranging, flash spotting, or extensive aerial reconnaissance. German tactical doctrine had eliminated the first three possibilities through careful positioning and tactical discipline. The fourth required sustained air superiority and favorable weather conditions, neither of which existed over the Hürtgen Forest during the October fighting. At the Divisional Artillery Headquarters in Düren, Oberst Ludwig Hartmann studied intelligence summaries that painted an increasingly disturbing picture. The phenomenon was not isolated to the Hürtgen Forest. Similar reports were arriving from artillery units along the entire Western Front. From the Vosges Mountains in the south to the Scheldt Estuary in the north, German artillery batteries were suffering unprecedented casualties from counter-battery fire delivered with impossible accuracy and speed. Hartmann had requested emergency consultations with the technical staffs at Army High Command. The response had been typically bureaucratic. American artillery techniques had improved, German batteries needed better camouflage discipline, commanders were exaggerating Allied capabilities to excuse tactical failures. None of these explanations addressed the fundamental impossibility of what field units were reporting. The mathematics alone should have prevented what was happening. Sound ranging, the most advanced counter-battery technique in German tactical doctrine, required multiple listening posts positioned at precise intervals, sophisticated timing equipment, and extensive calculations to triangulate enemy gun positions. Even under ideal conditions, the process required 15 to 20 minutes to develop firing data accurate enough for effective counter-battery fire. The Americans were accomplishing the same results in less than 5 minutes in heavily forested terrain that should have made sound ranging extremely difficult. Flash spotting presented even greater technical challenges. Artillery muzzle flashes, visible for only fractions of seconds, had to be observed simultaneously from multiple positions to develop accurate triangulation data. The Hürtgen Forest's thick canopy eliminated most flash signatures, and October weather conditions included frequent fog and rain that should have made optical observation nearly impossible. Yet American counter-battery fire continued with undiminished accuracy, regardless of weather conditions or time of day. The prisoner interrogation reports added another layer to the mystery. German artillery crews captured during American offensives described Allied counter-battery responses that began almost simultaneously with German firing. Several prisoners reported that American shells were impacting their positions while German rounds were still in flight toward their targets. The timing suggested that American forces were detecting German artillery activity and developing firing solutions faster than the German shells could complete their ballistic trajectories.
Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story.
And effective aerial reconnaissance methods. None of these technologies could account for the speed and accuracy of Allied counter-battery fire. The assessment concluded that American forces had either achieved unprecedented improvements in conventional techniques or had developed entirely new methods for locating enemy artillery positions. The human cost of the mystery was mounting daily. Artillery units that had survived the Russian campaign, fought through North Africa, and endured the Italian mountains were being systematically destroyed in the forests of Western Germany. Experienced gun crews, trained over years of combat, were being eliminated at rates that German replacement systems could not sustain. Battery commanders with decades of experience were requesting transfers to infantry units, preferring the risks of close combat to the impossible vulnerability of serving in artillery units. Morale reports from artillery units painted a picture of growing desperation. Gun crews spoke of being hunted by an invisible enemy that could locate them anywhere, at any time, regardless of concealment or tactical precautions. Some batteries had resorted to firing single rounds before immediately displacing, abandoning effective fire missions to avoid counter-battery destruction.
Others had begun refusing fire missions altogether, claiming equipment failures rather than risking exposure to American counter-battery fire. The tactical implications extended far beyond individual artillery units. German defensive doctrine depended heavily on concentrated artillery fire to break up American attacks and inflict casualties on advancing infantry. If artillery units could not deliver sustained fire without facing immediate destruction, the entire defensive strategy became untenable. Infantry units were reporting inadequate artillery support, while artillery commanders explained that sustained firing meant certain annihilation. Intelligence officers at Army Group B headquarters in Bad Neuenahr received increasingly desperate requests for information about American counter-battery techniques. Field commanders wanted to know what new equipment the Americans were using, how it worked, and most importantly, how it could be defeated or avoided. The intelligence response was consistently unsatisfactory. No evidence of new American equipment had been captured or identified. Prisoner interrogations revealed nothing unusual about American artillery procedures, and technical analysis could not explain the observed phenomena. The failure to understand what they were facing led to increasingly desperate countermeasures. Some artillery units began employing elaborate deception techniques, using dummy positions and false flash signatures to confuse American observers. The results were uniformly negative. American counter-battery fire continued to target actual gun positions with the same devastating accuracy. Other units attempted to overwhelm American responses by firing all batteries simultaneously, hoping to saturate whatever detection system the Americans were using. These tactics resulted in higher German casualties as more guns were exposed to counter-battery fire at the same time. Communication intercepts suggested that American artillery units were operating with information sources unavailable to German forces. Radio traffic analysis indicated that American battery commanders were receiving precise targeting data from sources identified only by numerical codes. The coordinates being transmitted were accurate enough to achieve direct hits without adjustment or bracketing fire. German communications intelligence specialists could not determine the source of this targeting information or the methods used to develop it. The technological disparity was becoming apparent in other areas as well. American artillery units were demonstrating sustained rates of fire that German logistics doctrine suggested should be impossible. While German batteries were rationing ammunition and limiting fire missions to preserve their limited supplies, American units were engaging
multiple targets simultaneously with what appeared to be unlimited ammunition reserves. The combination of superior detection capabilities and unlimited ammunition was creating a tactical environment where German artillery units faced certain destruction if they revealed their positions through firing. Weather analysis reports from the Wehrmacht Meteorological Service confirmed that conditions over the Hürtgen Forest during October 1944 should have severely limited optical observation and sound-ranging effectiveness. Persistent fog, frequent rain, and low cloud cover created conditions that German doctrine identified as optimal for concealed artillery operations. American counter-battery effectiveness showed no correlation with weather conditions, maintaining the same accuracy and response times regardless of visibility or atmospheric conditions. The psychological impact on German artillery crews was becoming as significant as the material losses. Veterans who had survived years of combat were expressing fear about serving in artillery units. Gun crews were requesting transfers to assault infantry units, traditionally considered far more dangerous assignments. The invisible nature of the threat was particularly demoralizing. Crews could not see what was detecting them, could not understand how they were being located, and could not develop effective countermeasures against an enemy capability they could not comprehend. Battery commanders began implementing increasingly restrictive firing procedures in desperate attempts to avoid detection. Some units limited themselves to single rounds before displacing, making effective fire support nearly impossible. Others attempted to fire from multiple positions in rapid succession, hoping to confuse American detection systems. These tactics proved ineffective and often resulted in higher casualties as more positions were exposed to counter-battery fire. The intelligence picture became more puzzling as German technical teams analyzed crater patterns from American counter-battery strikes. The accuracy suggested that American forces possessed precise coordinates for German gun positions before firing commenced. Crater analysis indicated that American shells were impacting within meters of German guns, accuracy levels that required either direct observation or extremely precise targeting data. Neither explanation fit the tactical circumstances under which the engagements were occurring. Forward observers reported that American counter-battery fire often originated from positions beyond visual range, sometimes from batteries located several kilometers behind American front lines. The distances involved should have made accurate indirect fire extremely difficult without sophisticated fire control systems and precise targeting data. German artillery doctrine required extensive preparation and careful coordination to achieve similar accuracy at comparable ranges. American forces were accomplishing the same results apparently without preparation time or adjustment fire. The cumulative effect of sustained counter-battery losses was forcing major changes in German tactical doctrine. Artillery units that had previously provided close support to infantry formations were being pulled back to positions beyond American counter-battery range. This reduced the effectiveness of German defensive fire and made it more difficult to break up American attacks. Infantry commanders complained that artillery support was becoming ineffective, while artillery commanders explained that forward positions were untenable under current conditions. Supply problems were compounding the crisis. German artillery units were consuming ammunition at unprecedented rates as they attempted to deliver effective fire missions before being forced to displace by counter-battery fire. Logistics units reported difficulty maintaining ammunition supplies to batteries that were firing rapidly and then immediately moving to new positions. The combination of high ammunition consumption and frequent displacement was straining German supply systems beyond their capacity.
Capacity. Training programs for replacement artillery personnel were being modified to address the new tactical environment. New gun crews were being taught to expect immediate counter-battery fire and to prioritize rapid displacement over accurate firing. These changes represented a fundamental shift away from the precision firing techniques that had made German artillery effective throughout the war. Veterans expressed concern that the new tactics would reduce German artillery effectiveness to levels that could not support defensive operations. Medical reports from artillery units confirmed the devastating effectiveness of American counter-battery fire. Casualty rate among artillery personnel exceeded those of infantry units engaged in active combat. The precision of American fire resulted in high percentages of killed versus wounded, suggesting that shells were impacting directly on gun positions rather than in surrounding areas. Medical personnel reported difficulty treating casualties because aid stations were reluctant to position themselves near artillery units that were certain to be targeted. The strategic implications were becoming clear to senior German commanders. If artillery units could not operate effectively without facing immediate destruction, German defensive capabilities would be severely compromised. Artillery had been the primary means of inflicting casualties on attacking American forces and disrupting their offensive operations. The loss of effective artillery support would force German forces to rely primarily on small arms and individual weapons, dramatically reducing their defensive firepower. Communications security measures were implemented in response to speculation that American forces were intercepting German radio transmissions to locate artillery positions. Artillery units began operating under strict radio silence, using landline communications and messenger systems to coordinate fire missions. The results provided no improvement in survival rates, indicating that American detection methods did not depend on intercepted radio communications. Camouflage experts from the Reich Ministry of Armaments arrived to assess German concealment techniques and recommend improvements. Their analysis concluded that German artillery units were employing appropriate camouflage methods and that their positions should be invisible to conventional observation techniques. The expert recommendations included more elaborate concealment measures, but field trials demonstrated no improvement in survival rates. American counter-battery fire continued to locate and engage German positions regardless of concealment efforts. The failure to develop effective countermeasures led to increasingly desperate measures. Some artillery units attempted to operate only during periods of heavy rain or fog, hoping that weather conditions would interfere with American detection systems. Others tried firing from positions inside buildings or other structures that would provide overhead cover from aerial observation. None of these techniques proved effective, and American counter-battery accuracy remained constant regardless of tactical modifications. Intelligence summaries from other sectors of the Western Front confirmed that the phenomenon was widespread. German artillery units from the North Sea to the Swiss border were reporting similar experiences with devastating American counter-battery fire. The consistency of the reports indicated that American forces had developed systematic capabilities rather than achieving isolated tactical successes. The scope of the problem suggested that fundamental changes in artillery warfare were occurring across the entire front. Technical analysis teams studying captured American equipment found no evidence of revolutionary new technologies. American artillery pieces, ammunition, and associated equipment appeared to be conventional designs similar to German systems. Communications equipment captured from American artillery units showed no unusual characteristics that might explain their superior counter-battery performance
Capabilities. The mystery deepened as German experts found nothing in captured equipment that could account for the observed American advantages. The human intelligence network operating behind American lines provided no useful information about American artillery techniques. Agents reported normal artillery operations with no evidence of unusual equipment or procedures. American battery positions appeared to be conventionally organized and equipped. The sources of their superior counter-battery capabilities remained completely invisible to German intelligence services. As October 1944 progressed into its final weeks, the crisis facing German artillery units in the Hürtgen Forest was spreading to other sectors and threatening to undermine German defensive capabilities along the entire Western Front. Artillery commanders were requesting emergency conferences to address the situation, while senior officers were demanding explanations from intelligence services that had no answers to provide. The statistics compiled by Colonel Brenner's staff painted a picture of systematic destruction that defied conventional military logic. In 3 weeks of fighting, his artillery regiment had lost 67% of its guns and 73% of its experienced personnel. The replacement equipment arriving from German factories was being destroyed as quickly as it could be deployed. Replacement personnel, hastily trained and inexperienced, were being killed or wounded before they could master their duties. The impossible had become routine. American forces were locating and destroying German artillery positions with a precision and speed that German military science insisted was technically impossible. The mystery that had begun with confused casualty reports was developing into a technological catastrophe that threatened to eliminate German artillery as an effective combat force. And throughout the crisis, German intelligence services could provide no explanation for what was happening or how it might be stopped. What Colonel Brenner and his artillery commanders could not have known was that they were facing the most closely guarded technological secret of the Allied war effort, a system so revolutionary that it was classified at the same security level as the Manhattan Project. The AN/TPQ-3 counter-battery radar system had been operational since August 1944, and by October, American forces had deployed 17 of these units along the Western Front, each one capable of detecting and tracking artillery shells in flight with a precision that German military science considered physically impossible. The technology that was systematically destroying German artillery positions had its origins in a top-secret research program initiated at the Massachusetts Institute of Technology's Radiation Laboratory in early 1943. Dr. Margaret Hutchinson, a radar engineer who had previously worked on early warning systems for the Royal Air Force, was tasked with solving what many considered an unsolvable problem: developing radar equipment capable of tracking artillery shells during their ballistic flight and calculating reverse trajectories accurate enough to enable immediate counter-battery fire. The technical challenges appeared insurmountable. Artillery shells traveled at velocities exceeding 700 meters per second, following ballistic trajectories that lasted only 30 to 40 seconds from firing to impact. The radar system needed to detect these small, fast-moving objects within seconds of launch, track their flight paths with extreme precision, and calculate reverse trajectories accurate enough to pinpoint gun positions within a few meters. The computational requirements alone seemed to exceed the capabilities of any existing electronic equipment. German scientists had investigated similar concepts during their own radar development programs. Teams at the Telefunken research facility in Berlin had concluded that the combination of detection accuracy, tracking precision, and computational speed required for effective counter-battery radar.
Technological capabilities. Their assessment, completed in early 1943, determined that such a system would require at least a decade of additional research and development to achieve operational status. The breakthrough came through an unexpected convergence of several independent American research programs. The MIT team's radar development work was combined with electronic computing research being conducted at the University of Pennsylvania's Moore School of Electrical Engineering. The Pennsylvania team had developed prototype electronic computers for ballistic calculations, machines that could perform complex mathematical operations at speeds previously thought impossible. Dr. Hutchinson's team realized that by integrating high-frequency radar with electronic computing, they could create a system capable of real-time ballistic trajectory analysis. The radar would detect incoming shells, track their flight paths, and feed trajectory data to electronic computers that would calculate point-of-origin coordinates within seconds of detection. The computed coordinates would then be transmitted directly to American artillery batteries, enabling immediate counter-battery fire. The first prototype system underwent testing at the Aberdeen Proving Ground in Maryland during the winter of 1943. The initial results were promising, but revealed significant technical challenges. The radar had difficulty distinguishing artillery shells from other airborne objects, and the electronic computers were prone to failures under field conditions. The system required extensive refinement before it could achieve operational reliability. By spring 1944, the development team had solved most of the technical problems. The radar's discrimination capabilities were improved through advanced signal processing techniques that could identify the distinctive radar signatures of artillery shells. The electronic computers were ruggedized for field deployment and provided with backup systems to ensure continuous operation. Most importantly, the system's accuracy was refined to provide coordinate data precise enough for effective counter-battery fire. The production program represented one of the most ambitious electronics manufacturing efforts of the war. Western Electric Corporation was selected as the primary contractor, with additional components provided by General Electric, RCA, and Bell Telephone Laboratories. The complexity of the system required unprecedented coordination between multiple manufacturers, each responsible for specific subsystems that had to integrate seamlessly with components produced by other companies. Manufacturing began in earnest during the summer of 1944. Each AN/TPQ-3 unit contained over 2,800 individual electronic components, including 347 vacuum tubes, 89 specialized transformers, and 156 precision-manufactured capacitors. The radar antenna alone required machining tolerances measured in thousandths of inches, precision levels that pushed American manufacturing capabilities to their limits. The electronic computers integrated into each system represented cutting-edge technology for 1944. Each unit contained 18,640 individual electronic components, arranged in circuits that could perform complex mathematical calculations at speeds of over 5,000 operations per second. The computers were programmed with ballistic tables that accounted for atmospheric conditions, shell types, and trajectory variations, enabling accurate reverse trajectory calculations under a wide range of conditions. Quality control procedures for the counter-battery radar program exceeded those of any previous electronics manufacturing effort. Every component underwent individual testing before assembly, and completed systems were subjected to comprehensive performance evaluations that simulated actual combat conditions. Less than 4% of manufactured units failed to meet operational specifications, a remarkable achievement given the complexity of the technology. The security measures surrounding the program rivaled those of the atomic bomb project. Workers were required to obtain special security clearances, and production facilities were isolated from other manufacturing areas. Even the program's code name, Project Flashlight, was deliberately misleading, suggesting a conventional illumination system rather than revolutionary radar technology. Training programs for radar operators began in June 1944 at a classified facility near Fort Sill, Oklahoma. Selected personnel underwent 8 weeks of intensive instruction in radar operation, electronic maintenance, and tactical employment. The training emphasized security procedures as much as technical competence, with operators sworn to absolute secrecy about the system's capabilities and methods of operation. The first operational deployment occurred during the Normandy breakout operations in late July 1944. 2 AN/TPQ-3 systems were positioned behind American lines in the Cotentin Peninsula, where they underwent combat testing against German artillery positions. The results exceeded all expectations. German batteries that had been harassing American positions for weeks were located and destroyed within hours of the radar systems becoming operational. German intelligence services remained completely unaware of the new technology. Intercepted radio communications indicated that German artillery commanders attributed their losses to improved American spotting techniques and better coordination between forward observers and artillery units. No German reports suggested awareness of revolutionary new equipment or techniques. The tactical impact was immediate and devastating. American artillery batteries equipped with counter-battery radar data could engage German positions before enemy guns could complete their first fire missions. The traditional artillery duel, where opposing batteries exchanged fire while attempting to locate and destroy each other, was replaced by systematic annihilation of German positions by American forces who knew exactly where their enemies were located. The system's effectiveness was enhanced by integration with American artillery doctrine that emphasized rapid response and overwhelming firepower. When the AN/TPQ-3 system detected German artillery fire and calculated gun positions, the coordinates were immediately transmitted to multiple American batteries. Instead of engaging with single guns, American forces would respond with coordinated fire from 6 to 8 batteries simultaneously, ensuring complete destruction of German positions. Communication procedures were developed to maximize the system's tactical value while maintaining operational security. Radar operators used coded transmissions to relay targeting data, with coordinate information disguised as routine logistical reports. German radio intercept units monitoring American communications detected no unusual traffic patterns or suspicious transmissions that might indicate the presence of special equipment. The psychological warfare value of the system became apparent within weeks of deployment. German artillery units began reporting mysterious losses that they could not explain or prevent. Gun crews described feeling hunted by an invisible enemy that could locate them anywhere, at any time, regardless of concealment or defensive measures. Morale in German artillery units plummeted as crews realized they faced an enemy capability they could not understand or counter. By September 1944, 17 AN/TPQ-3 systems were operational along the Western Front. The concentration of counter-battery radar coverage meant that German artillery positions across the entire front were vulnerable to immediate detection and engagement. No sector remained safe for German artillery operations, and the cumulative effect was the virtual elimination of German artillery as an effective combat force.
Each representing over 8,000 hours of skilled labor and components sourced from dozens of specialized manufacturers across the United States. German intelligence estimates suggested that such production rates should have been impossible given the complexity of the equipment. Maintenance and logistical support for the systems required extensive infrastructure development. Each radar unit required a technical support team of 12 specialists, including radar technicians, electronics engineers, and communications operators. Spare parts inventories contained over 400 different components, and mobile repair facilities were established to provide field maintenance capabilities. The security protocols surrounding operational deployment ensured that German forces never obtained detailed information about the system's capabilities. Radar operators were instructed to destroy their equipment rather than allow capture, and special security detachments were assigned to protect radar sites from German infiltration attempts. Throughout the war, not a single AN/TPQ-3 system fell into German hands intact. Weather conditions that German forces hoped would interfere with American counter-battery capabilities proved ineffective against the radar technology. The AN/TPQ-3 system operated effectively in rain, fog, and darkness, conditions that severely limited conventional observation methods. German artillery units found no refuge from American counter-battery fire, regardless of weather or tactical circumstances. The computational capabilities of the system enabled tactical innovations that further enhanced its effectiveness. The electronic computers could simultaneously track multiple artillery trajectories, allowing American forces to engage several German batteries at once. When German forces attempted to overwhelm the system by firing all their batteries simultaneously, the result was simply faster detection and engagement of more targets. Integration with American fire control systems created a seamless process from detection to engagement. Radar operators could transmit firing data directly to artillery battery fire direction centers, where the coordinates were fed into mechanical computers that calculated firing solutions for American guns. The entire process, from detection of German muzzle flash to American shells leaving their tubes, required less than 3 minutes under optimal conditions. The accuracy of the system exceeded German comprehension. American counter-battery fire was achieving direct hits on German gun positions with such consistency that German commanders suspected treachery within their own ranks. Security investigations found no evidence of espionage, leaving German leaders to conclude that American artillery capabilities had somehow achieved revolutionary improvements through unknown methods. German attempts to develop countermeasures proved futile because they were addressing the wrong problem. Believing that they faced improved conventional techniques rather than revolutionary technology, German forces implemented camouflage improvements, communication security measures, and tactical modifications that had no effect on radar detection capabilities. Their countermeasures were designed to defeat human observers rather than electronic systems. Technical intelligence gathered from prisoners and captured equipment provided German forces with no useful information about American capabilities. American artillery units appeared to be equipped with conventional weapons and standard communications equipment. The radar systems were positioned well behind American lines and were never encountered by German reconnaissance patrols or intelligence operatives.
Equipped to implement, given their reduced manpower and limited resources. American commanders began exploiting their counter-battery advantages by deliberately provoking German artillery fire. By conducting conspicuous movements and presenting attractive targets, American forces could induce German batteries to reveal their positions through firing. The German response would be immediately detected by counter-battery radar, leading to swift destruction of the enemy guns. The industrial and technological gap between American and German capabilities became starkly apparent through the counter-battery radar program. While German factories struggled to produce conventional artillery pieces using increasingly scarce materials and forced labor, American industry was mass-producing revolutionary electronic systems that represented the cutting edge of 1940s technology. Production statistics revealed the scope of American technological superiority. By war's end, American factories had produced 47 AN-TPQ-3 systems, each containing components that represented the equivalent manufacturing effort of approximately 12 conventional artillery pieces. The total program cost exceeded $89 million, a sum that German war production could not have allocated to a single weapons system. The human cost of German ignorance about American capabilities was measured in thousands of artillery personnel killed or wounded by counter-battery fire they could not understand or avoid. Experienced gun crews, trained over years of combat, were eliminated at rates that German replacement systems could not match. Many of Germany's most skilled artillery officers were killed while attempting to employ tactics that were effective against conventional threats but suicidal against radar-directed fire. The psychological impact on German artillery units contributed to the broader collapse of German military morale during the final months of the war. Artillery crews who had previously taken pride in their technical competence and tactical skill found themselves helpless against an enemy capability they could not comprehend. The traditional confidence of German artillery units, built through successful campaigns across Europe, was systematically destroyed by technology they never knew existed. American forces began using their counter-battery superiority for purposes beyond simple artillery destruction. By tracking German shell trajectories, the radar systems could provide intelligence about German artillery deployment patterns, ammunition types, and tactical procedures. This information proved valuable for planning offensive operations and predicting German defensive capabilities. The security success of the program was as remarkable as its technical achievement. Throughout 18 months of operational deployment, German intelligence services never determined that American forces possessed revolutionary counter-battery capabilities. German explanations for their artillery losses consistently attributed them to conventional causes: improved American training, better coordination, superior numbers, or enhanced conventional techniques. Post-war interrogations of captured German artillery officers revealed complete ignorance about American counter-battery radar capabilities. Senior German commanders expressed surprise upon learning that electronic systems had been responsible for their artillery losses. Many refused to believe that such technology had been operational during the war, insisting that their losses must have resulted from conventional causes. The technological foundation established by the counter-battery radar program provided the basis for post-war developments in electronic warfare, missile defense, and precision-guided weapons. The integration of radar detection with electronic computation represented a fundamental advancement in military technology that influenced weapons development for decades after the war's end. The AN-TPQ-3 system demonstrated that in modern warfare, technological advantages could have decisive consequences.
Superiority could provide decisive advantages that transcended numerical or tactical factors. German artillery units, despite their experience, training, and tactical competence, were rendered ineffective by American technology they could not detect, understand, or counter. The invisible nature of their defeat made it particularly demoralizing and contributed to the broader German recognition that they faced an enemy with technological capabilities beyond their comprehension. The counter-battery radar program represented more than a successful weapons system. It embodied American industrial democracy's ability to mobilize scientific resources, manufacturing capacity, and human creativity for military purposes. The program's success resulted from collaboration between universities, private corporations, and military organizations, a form of cooperation that totalitarian systems found difficult to achieve. The secrecy that protected the program throughout the war was maintained through compartmentalization, security procedures, and careful operational planning rather than through repression or fear. American workers and scientists contributed to the program's success while knowing only their specific roles, trusting that their efforts served important purposes even when they could not see the complete picture. By the war's end, the ANN-TPQ-3 counter-battery radar system had fundamentally altered the nature of artillery warfare. German forces that had begun the war with superior artillery doctrine and experienced personnel found themselves outmatched by American technology that detected and destroyed their positions faster than human reflexes could respond. The psychological impact was as significant as the material losses, as German artillery crews realized they faced an invisible enemy they could never hope to defeat. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.